Good afternoon. My name is Yang Xu. I am a software engineer at Data Platform of Data Engineering Center. I have been working on the building of data pipeline and batch ingestion for over 5 years. I also develop efficiency tools for internal usage. And my vision is that everyone can enjoy data easily with services we provide. Today, firstly, I would like to talk about the status and problem of ETL batch at Line. And then I want to share our consideration and introduce a unified managed workflow service as our solution, including goal and feature. And last, I will talk about some important works to be done in the future. ETL batch acts prominently in data pipeline of our company. There are around 100,000 batch jobs running every day, conducted by over 200 users, serving about 40,000 tables using reporting, analysis, machine learning, and other fields. We have an ETL team in data platform department to handle batches. This team maintains an Azkaban instance with a Python-based ETL job framework. Members of ETL team take responsibility to communicate with other teams outside data platform department, creating and looking after batch jobs for those teams. On the other hand, many teams, for example, official account team and data scientist team, handle batches on their own. They code in languages that they are familiar to, and then schedule on some other platform like Airflow and Oasis. Current situation seems good enough because data platform users can choose to handle batch freely or get help from ETL team. But is everyone happy in real practice? Let's see what's happening if a user decides to handle by himself. First, he needs to guarantee a machine, set up the scheduler, and take care of both the machine and the scheduler. And then he should design and develop necessary functionality for his scheduler, like data validation, task retry, alerting, notification, and so on. And last, the most important thing is he must make sure he can write executable and reliable codes to make everything work. It may not be difficult for a data engineer to get all those things done, but it does cost too much for a normal user without much experience about coding and data engineering. In the meanwhile, data platform admins also suffer a lot. There often comes an inquiry about irregular job behavior, which is caused by careless scheduling and configuration. What makes things worse is components of data platform can become unstable due to bad queries and wild operations submitted by user. Let's see a real case. Here are 4 paragraphs taken from an Oasis job of some team. This team makes use of Scala to create Spark jobs. From the first paragraph of create job, we can see that they have developed several libraries. And in the paragraphs of check partition and generate new partition, they are trying to get proper partition key, verify current partitions, and then execute queries of data processing. By the way, when query finish, they remember to merge small files kindly. And last, they also want to get notification about job status through Slack. In fact, for this team, only the 500-line queries in the left below paragraph matter to their business. It takes too much time for them to prepare other parts to get their ETL job work. And then, though Oasis can be set to execute the paragraph periodically, to act as a scheduler, it still lacks a function, such as task dependency. Oasis can only execute sequentially, as is shown in the upper screenshot. Another critical point is there is no version control in the practice of some teams. For example, Oasis users can only manage files by directory. Now, our goal becomes clear. We need an ETL system which is central controlled yet easy to use. With this system, the burden of data engineering, like setting, encoding, and compression, and merging small files, as well as operation costs such as task retry and recovery, should be cut off for normal users. At the same time, data platform admins can apply proper configurations and restrictions to all the jobs running on this platform. Considering all those pain points, we started to build and provide a new workflow service for overall line staffs. This service should have at least 3 key features. The first one is we data platform side should hold only one unified platform and avoid setting up different kinds of schedulers or multiple instances of a scheduler. By doing that, we can make it easy to develop, manage, and maintain. At the same time, users can be freed from such things which they are not good at. Then, we should provide a series of standardized functionality for users to make sure all the jobs and operations are under control. This can avoid potential duplicate deployment driven by different teams as well. And last, we should try to make the creation of job codeless. Users are not expected to have advanced coding skill, and it is enough that they ensure their query can work without problem. In order to host a unified platform, we believe that 3 properties should be met. The first is high availability. The system should be able to run applications stably and reliably without downtime. For example, update and restart should not affect user access and operation. And second is extensibility. It should be easy for us to define and integrate functionalities to the system because we need to fit the diverse needs of users. And the third is scalability. We want the whole system to scale up and out conveniently to get prepared for the increasing workload and various conditions in the future. In our practice, we chose Airflow on Kubernetes to build the unified platform. We can get high availability with the help of Kubernetes, and Airflow supports extensible plugins. Also, we can scale up and out easily on both Kubernetes level and Airflow level. Furthermore, let alone Kubernetes, Airflow community is very active, which means that we can both get support and contribute our code easily. And the next point is standardized functionality. As data platform admins, we know that it is dangerous and irresponsible to let users execute jobs at will. There are always careless operation, bad configurations, unoptimized queries, which are making our services unhealthy. At the same time, users of different teams may develop the same libraries of functions, which is a waste of human resource. So it is necessary that we provide official standardized functionality to both protect Hadoop cluster from unexpected user behavior and make the workflow service easy to use. Here are functionalities we have done and are working on. The first is engine. Currently, several kinds of engines, such as Hive, Spark, and Tez, are available in our data platform. But as to the new workflow service, we should use only one of them, because only by this way, we can develop and provide a series of standardized functionalities efficiently. In practice, we chose to use the latest Spark 3 as the main execution engine after our investigation. And then operator, we analyze the task types of ETL batches and conclude that SQL and data move account for the majority. And we need to make operations under control within job execution as well. And about its data quality, users can perform profiling, verification, and anomaly detection on their data. About notification, users can get messages about job status through Slack and email. And then dependency. In order to guarantee data delivery time and perform less human intervention when failure of upstream job happens, we should be able to set up that task dependencies both in and across jobs. And the last is SLA. Users can set SLA of data landing time and job execution time for easy monitoring and detection. Unified platform and standardized functionality are about development, but Codeless reflects our design philosophy. From daily experiences, we conclude that users hope to focus on their own business logic other than data engineering, and data platform administrators want to prevent troubles caused by unexpected behavior in user jobs. If users just provide core logic of data processing and tell us how they want it to be executed, and we put all those parts together to make it executable, problems on both sides can be resolved. So we came up with the solution called Job as Config. We predefine several kinds of config templates. Users just pick out what they need, fill in some forms, and submit. And then we pass and transform config files to executable job at runtime. And in the meanwhile, we intentionally make ETL job independent from the backend scheduler. This enables us to provide our own middleware to users to manage job better, and we will also be able to hide specific scheduler from users in the future. By this way, users will not be demanded to learn to use schedulers like Airflow. And furthermore, we can handle easily when scheduler migration happens. Let's move on to see an example of config template. The first is job. Job defines a complete data pipeline. It holds global configurations. We use service information to set proper permission for multi-tenant environment. And description will be shown on the web page so that team members can know about this job easily without checking details. Maintainer defines who takes responsibility for this job. Users can decide where to send a message and the retry strategy by notification and retry fields. Also, since there are various users located in East and Southeast Asia, we support time zone aware feature to solve potential issues caused by time zone conversion. And last, job refers tasks by task name and defines dependency of them. Now let's have a look at task template. We prepared specialized templates for each type of task, such as Spark SQL and disk copy. Parameterization is available for all the fields in this config file. In this case, you can see two parameters are defined. They are used in data validation and query fields below. This is powerful because user can create and update tasks in a flexible way. And it is necessary to support user-defined functions. Users can import UDF from our trusted repositories. Data validation can be performed before and after query execution for both data source and result table. And other features like data retention are also available. Old data will be purged automatically in the task execution processing. When job and task config files are ready, how are they transferred to a real executable job? One solution is to make use of some template tools like Jinja 2, by which we render script templates with configs. This is feasible, but we have to manage rendered files Furthermore, it is not strict enough because it introduces extra steps to development. In our practice, we generate job dynamically. As it's known, Airflow scans its DAG folder to create DAG. So we create a DAG script where configs are loaded and DAG objects are created at runtime. We can perform similar processing to generate job dynamically, even if we switch to some other schedulers other than Airflow. Now let us check what a job will be like on Airflow. We can see that our config is transferred to a real DAG. There are documentations describing this job, and the pink circle shows this DAG consists of 2 Spark SQL tasks, and everything works fine. Finally, we come to the architecture of our workflow service. We made effort to build it as simple as possible. Code and user configs are managed in GitHub. Once released, they are deployed to Kubernetes cluster. Airflow runs with Kubernetes executor, so we need not to set extra message broker like Redis and extra salary workers. When task pod is created, it submits Spark application to Yarn. When job finishes, Airflow task instance sends message to Slack or email as user have set in their job configs. Of course, user can access Airflow server to check and operate on their own DAGs. We have achieved several results since we released our new service to production. Contrary to the previous situation that ETL codes are scattered everywhere, we now keep them in one centralized place and can find one specific job easily. At the same time, we take back from users the control of configurations which may affect cluster components. For example, we apply daily compression to all ORC formatted tables to get better performance and less disk usage. While in old days, there existed ORC plus Snappy and other combinations set by user. Users also find the new working style more productive. Thanks to job as config, they have more time to concentrate on the business logic itself and can read and understand other ETL jobs easily without much programming knowledge. Before finishing, let me talk about our future work. Data quality. We will keep enhancing current features, especially anomaly detection, and try to introduce more detailed features like column analyzer and data cleaning. About data lineage, we want to integrate ETL jobs with our internal data catalog tool to provide better lineage service for users. And about data connectivity, we would like to support more data storages and make it easier to execute ETL jobs across different kinds of data sources. For example, we can perform queries such as join data from MySQL and Hive tables. And we are hiring. Thank you.